In this video, we compare descriptive and inferential statistics. Now, in previous videos, we talked about populations and samples and the point that characteristics of the population, like the population mean, are called parameters, and things we calculate from our samples, like the sample mean, are called statistics. But there's also a term that researchers use called descriptive statistics. Descriptive statistics strictly just describe our data. To see what I mean, let's stick with our previous example of how many hours each week students at UMaine study. If I sample 40 students and find that the average is 20 hours per week, that's a descriptive statistic. Students in my sample had a mean of 20 hours per week. Maybe the maximum in my sample was 38 hours per week. That's another descriptive statistic. Descriptive statistics can also tell you how spread out the data are that you have. Notice I'm emphasizing the data you have. We're going to learn ways to calculate how spread out scores are. Do all 40 students in my sample study close to 20 hours per week? Or maybe half never study and half study 40 hours per week. They'd both give me a mean of 20. How spread out the scores are in my sample is another descriptive statistic. How big my sample is, that's also a descriptive statistic. And there's more. Now, key to descriptive statistics is that you've calculated them. There's no guessing here, no estimating. You know what it is because you have the data and you calculated it. Now, descriptive statistics can also describe a sample or the population if you happen to have data for everyone in the population. Sorry, I don't make up the rules. We just don't use the term descriptive parameters if we happen to have data on the entire population and want to report the mean or something for the population. Now again, that rarely happens. So it's just not something worth tying yourself up in a knot over. So if you ever see a paper that Chaffin or I have published and we report the average birth weight for all the babies born in some state based on population data for that state, it may appear in a table titled Descriptive Statistics, even though it's the population parameter. In contrast, inferential statistics use our sample data to make inferences about the population. For example, if I want to use the mean number of hours students in my sample study as a way to estimate how many hours all students at the university study each week, I would use inferential statistics. Whereas I can calculate exactly what the descriptive statistics are because they're based on data I have in my sample, inferential statistics involve estimating things. I don't know how many hours all students study. I'm going to have to estimate it. This is why you'll hear things like, on average, college students study 20 hours per week, plus or minus 3 hours. Or 53% of voters support candidate Smith, plus or minus 2%. That plus and minus reflects the fact that we're estimating what the real value is. We'll get into that more later. A specific form of inferential statistics that we'll spend a lot of time with involves helping us determine whether what we think we see in our sample in fact reflects what's real out there in the population. If we see that females in our sample study more than males in our sample, does that mean that in the entire population of all students, females study more than males? Or did we just happen to randomly get a few studious females? if we see a new intervention helps improve social skills in preschool children in our sample, do we think it will improve social skills in all children if we applied it more broadly? Or was what we saw in our sample just some random chance? Now, to give you a sense of where we're going, let's take a quick peek at some of the descriptive and inferential statistics we'll cover in future videos. In terms of descriptive statistics, we'll see things like different measures of central tendency, things like means and medians. We'll look at different ways of describing how spread out our scores are, things like standard deviation and variance. Again, we haven't talked about those yet, but we will in the future. We'll also see how correlated two variables are. Again, we'll cover this in future videos. In terms of inferential statistics, we'll spend time going through a series of different statistical tests and tools for different types of questions and different types of data. These include z-tests, t-tests, analysis of variance, and the chi-square test, as well as a tool called interval estimation. Again, we'll cover these in future videos. It's worth noting that when people think of statistics and statistics courses, they're often thinking about all of these different types of tests. So let's say that I sample 40 students of the 10,000 students at UMaine and find that they study on average 20 hours per week. That 20 hours per week is a descriptive statistic. It describes the sample. I've calculated it exactly. I know what it is. If I use it with some techniques we'll learn later to conclude that students at UMaine study an average of 20 hours per week, plus or minus 3 hours, that plus or minus 3 hours makes it an inferential statistic. I don't know exactly how many hours all 10,000 students study. I'm estimating it. But if I actually go out and ask every single student, all 10,000 of them, how many hours they study each week, and I find that the mean is 19.3 hours per week, what would that be? That's also a descriptive statistic. It describes the population. I don't have to infer anything. I know exactly what it is, even though it's based on the entire population, because I actually assessed everyone in the population. Okay? One final flashback before wrapping up. So that 20 hours per week is our sample statistic, and that 19.3 hours per week is our population parameter. Okay? Hope that makes sense. Take care. Bye-bye.